I'm Johan van Holtz, Director of Amanziflow Projects, a company based in South Africa. I have a model here today which I'll explain to you, but before we get to that, let me tell you about the Amanziflow Scour gate. It's a non-electromechanical control gate, typically installed in the base of dams and weirs, which allows for automatic release of surplus water during high flow flood events, and it allows the flushing of accumulated sediment and organic detritus, which typically impounds at the upstream side of the wall, to be released downstream into the river below where it belongs. Unflushed, the sedimentation will then consolidate at the base of the wall, rapidly resulting in the loss of storage of our dams and weirs. The retroactive dredging and clearing of sediment from dams and weirs is prohibitively expensive. It's time consuming, and thus it's almost never done. The impoundment of sediment upstream is detrimental to the downstream river ecology, and the ability for us to flush the sediment back to the downstream river ecology has us then looking after the health of the river and the watercourses downstream. The model we have with us typically shows this representing the impoundment wall and the water storage upstream of the wall, where we have a buoyancy chamber, and below the buoyancy chamber is a scour channel, which is a passage for the sediment to be flushed from the base of the dam. If we simulate a flood event where we have increased supply level upstream, it is designed to start flooding the buoyancy chamber, and as the water level rises in the buoyancy chamber, the buoyancy tank will then start floating, where the buoyancy then overcomes the self-weight of the gate. It will rise, and the closure plate connected to the buoyancy tank will then rise, and in doing so open the passage through the scour channel. The rapidly rushing water through that will scour out the gravels, the sand, the sediment and the detritus downstream. As the water level then, as the flood event is passed, or the water level starts receding upstream of the wall, the flow into the buoyancy chamber slows down, eventually stops. The water continues to drain out of the buoyancy chamber, and the buoyancy tank, then connected to the closure plate, slowly recedes back to its original closed position. The closure plate, being the control element of the scour channel, maintains its closed position, and the water level will stop, and thus we maintain full supply level upstream so that we don't waste precious water. The typical applications of the scour gate are for cleaning up abstraction points, for pumps, water takeoffs, hydro takeoffs, etc. from channels and rivers, where the sediment contained in that water can be detrimental to the equipment that has to either pump or take the abstraction water. We have examples, a recently completed neck atoll on the Fish River Canyon of a scour gate which is 4 meters wide with a 2.3 meter high scour channel to clean up the abstraction points for the irrigation abstraction for very large irrigation system.